I'm happy to introduce to you all Mr. Randy Templeton, software engineer with Intel, who's going to talk about Linux Foundation Edge and the overview of FDO software components. Randy, welcome.
Thank you. Yeah, and I'm a software architect at Intel, as well as the technical chair lead for the LF-Edge FIDO device onboard project. And so I'll be walking through the resources that are available on LF-Edge for the implementation that we have there of the FIDO device onboard spec. And so I'll start sharing my screen here. Just the website here, and I'll be walking through again all the resources here that are available. And so this is, if you just go to lfedge.org, you'll see that this is the LF-Edge website. And if you see down at the bottom here, there's LF-Edge projects. And if you scroll, you might have to scroll a little bit. This is just a scrolling marquee that just keeps looping through. There's FIDO device onboard project there with a little cloud and an arrow there. That's the FIDO device onboard. You can also go to projects here and see it in this pop-up menu here. You can see FIDO device onboard. So once you go to FIDO device onboard here, you can click on here. This gives the benefits and history of the FIDO device onboard project. At the very bottom here, we have get the code, right? So I'll walk through the implementation that's available on the code. There's also a Slack channel you can join to answer questions. Mailing lists is if you, we do have bi-monthly meetings where we cover FIDO device onboard implementation, implementation discussions and so on these are technical advisory steering committee meetings. They're bi-weekly. You can join those and get scheduled to get access to those meetings. We have a wiki site, has articles like how to and so on as well. And then I'll just go through getting the code on GitHub. So once you from FIDO device onboard website, you can just get here to GitHub FIDO device onboard, and this contains the implementation. And if you look here, there's 7 repos. Really, only 2 are really important that you need. So some of these are for like continuous integration, some are documentation, but the notes. But the 2 that are really critical is PRI FIDO IoT and client SDK FIDO IoT. So PRI FIDO IoT is the main one you would use. PRI stands for Protocol Reference Implementation of FIDO. And if you click on this, this has the implementation of FIDO 1.1 proposed standard. And this is written in Java. It's containerized, so you can just run things as containers. And so we have the README here of the description of the project here. And under protocol samples, demo, we have demo deployments of these servers, again, as Docker containers. So the reason it's called samples and demo, this project, the implementation itself is production. How you deploy it, there's zillions of ways you can deploy it. We provide examples of how to deploy it as a Docker container. I've had people that they deploy it directly in VMs. You can deploy it in AWS or Azure. You can deploy it using Lightsail, Beanstalk. There's all kinds of ways to deploy it. So we have a demo sample way of deploying implementation. And so that's why it's called a demo. It's not that the entire implementation itself is demo. It's just this is a demo of how to deploy it. So under demo, we have these sub-projects under here. The owner is the implementation of the FDO a FIDO device owner. A manufacturer is an implementation of the device initialization protocol described in the spec, which is non-normative. You don't have to implement this, but we've implemented that for manufacturing FDO devices. And then we have an RV, which stands for rendezvous server. This implements the rendezvous server portions of the spec, the TO0 and TO1 server side of that protocol, while the owner implements TO2 and the TO0 client side of the protocol. We also have a reseller here. This is a web-based container that has REST APIs that allows you to extend ownership vouchers. So just through hosting this container and with REST APIs, you could submit an ownership voucher and get it extended or signed over to another owner. We also have a device here. This is a device that you can use for testing. It's implemented in Java, and this implements the device, and it basically simulates everything that a actual real device would do. DB is for database. So all of these services need data storage for things like ownership vouchers and keys and so on. So that's all done in a database, and this is a container. It's MariaDB based database. Although one thing to note is all of our services, they use a Java library called Hibernate Core, which abstracts away database, the actual database that you're talking to. So we can talk to MariaDB, we can talk to Postgres. We have customers that do Postgres, MySQL, MariaDB. Basically, there's a whole list of databases that library supports. But just for the sample demo, we use MariaDB, which is just an implementation of a specific implementation of MySQL. Then probably the most important one that you'll want to use starting out is the all-in-one. And so AIO just stands for all-in-one. This contains all these services basically in one package. So this is very convenient if you're doing development and tests, so you don't have to deploy all these individually or separately. You can just run the all-in-one, and that'll be a single service that can answer requests for manufacturing, for rendezvous, and for your owner, and has all the APIs for reselling as well. And so starting out, this is, I think this is probably your most convenient option, is just start the all-in-one and then use the device as to simulate your device. And then you can develop all your like service info exchanges that you want to do with the device. This implementation as of 1.1.7 supports the FSIM specification on FIDO. And so you can start building your service info and testing it with the test device and the all-in-one. And then once you have all that flow and everything working, then you can move on to deploying these things separately or using a different RV like the Intel publicly hosted RV, which is FDO, rvfdo.com. And you can start splitting these things out after you've got everything kind of working with the all-in-one and the Java device. So when you go into the deploying the all-in-one, there is a Docker Compose file. So you can Docker Compose up, and that would bring it up. And then any configuration, like what ports or anything that you want, can be done in a service YAML. We have a YAML config file there if you want to change everything. By default, all-in-one, everything will come up. HTTP requests will be answered on port 8080. And so, and that's for FDO devices that don't support TLS. They can communicate via 8080, but the FIDO protocol itself will secure the transport, even though it starts out with HTTP. And then it will answer TLS requests on port 8443, 88443. So and then there's REST APIs you can use also to configure once it starts up things like manufacturing address if you're doing the manufacturing side, load ownership vouchers that have been manufactured. One convenient thing about the all-in-one is to simulate manufacturing flow. You can run the device. If it doesn't have any credentials, it will run the device initialization protocol, get it, create keys, get everything set up, and it will automatically import the voucher into your the ownership database and automatically register it with the RV. That all happens automatically in the all-in-one. Normally, when you're these are separate entities, right? There's API calls and protocols that run to transfer these. But in all-in-one, we're assuming you're just doing this for development. And so it will, and you're running all these services together, they're bundled together. So they'll just internally talk to each other and set everything up. So then the next time you run the device, it will just start directly doing TO2 with your own. And so, again, you can deploy this as Docker. Also, you don't have to use Docker. You can. This is a Java application, so when you build it, and I have some slides here that I can go through on how to build it. You'll just do a Java -jar, and you can run it standalone, right? And that runs not in a non-container. It'll just run as a Java application. You would have to have Java installed on the machine that you're going to run it on. But if you run it as a container, the container will have Java, and it's going to also the container is doing is the same exact thing as that if you run it standalone outside the container. It's just going to deploy all the resources in the container and run the Java server, web server in the container. And so all-in-one is the basic again development server. If I go back out the main FIDO website here, you can see that we have on GitHub. This is still not taking me to. Here we go. The second one is CSDK, and this is basically a C implementation of the client only, right? So you would use this basically for production type devices that you can deploy, and these could communicate with the PRI FIDO IoT services, or again through interop, right? They can talk to any other implementation that is implementing the server end of the protocols. And so this C application, we have make files here where you can just go ahead and make and build that CSDK client. And there's instructions in there on how to configure it. Again, manufacturers would usually be deploying this on devices themselves, and then if you're you'd basically be configuring and just dealing with the PRI server end of the protocol. So also in terms of the on FIDO IoT to build it, there is a build container where this is a Docker container where you can Docker compose up here, and in Docker it will go ahead and build everything for you. So you don't have to. There are some tools that we use in Java. Maven is the Java build and package manager tool that pulls in all the dependencies and then builds the Java code for you. In this Docker container, it will handle all that. So you don't have to install those on your development system. You can just use this containerized version, which will build everything for you. And then it has defined in the compose file a shared volume on your host that will output all the build output. And so if I go through, I'll move this to full screen here. So this can walk through some of the this presentation, building the systems so you can deploy them as containers. So again, first step, just go to the GitHub website, go to the FIDO IoT project, and then if you look at, by default, that's going to get you to master. And if you go to the tags release, that's where our official releases are. We just released 1.17. I made this earlier this summer. This was this slide deck. This says the current version is 1.5, but we have 1.1.7 that is the most current version. Then you could just download that tagged released version. You can just extract it and then open a terminal to it. And again, you would then just edit the build script and change whatever directories you have on your system wherever you downloaded it to, and make sure that you install Docker. So this is just the instructions to make sure you have Docker installed. And once Docker is up and your permissions are set for Docker, you can go ahead and edit the Docker file again to pass to whatever volume you want to output the device to, and then that would, when you run that Docker container, it will build everything for you. Once you've built everything, by default, the containers require TLS and require mutual TLS for API calls, authentication, and so it's secured by default when you bring it out of the box. So you'll have to create certificates here, and these are the scripts that you can use to set up all the certificates. Now, you don't have to do this if you're doing development. There are ways that you can configure it to basically turn off TLS and even turn off, if you turn off TLS, obviously you can't use mutual TLS. So you can enable digest authentication for API calls. And so you can just use username, password, and non-TLS for your making your API calls for development. But these scripts will set up generate keys. You can also generate, if you're deploying this on an actual server that you want to publicly host, you can import those keys and certificates that were issued from to your website. Once you've set up the certificates, then you need to bring up the database, right? Now, again, there's many ways you can host your own database, right? Whatever database server you have, and you can just point the LF Edge servers to your own database. Again, we have MariaDB. We use MariaDB here, and this was just a config change that there was a config change you had to make to get the MariaDB to come up correctly. That's been fixed, so this step you can skip in the latest versions because we're using the latest version of MariaDB. And so then this is how you would bring up the AIO container. You would just CD into the container and do a Docker compose up. The first time you would do a -- build, you wouldn't have to do the -- build any subsequent times you're bringing up the container. Like if you've made configuration changes or anything like that, you can just bring it up. And then you can bring up a device. The device, just like the other containers, you can run it right on the command line outside of a container if you want, as long as you have Java. Or you can actually run the device itself in a container, right? And it will run as a container and communicate with the all-in-one server. The first time you run the device, it looks into a directory to see if it has any credentials. If it doesn't, it runs the device initialization protocol, and you'll see the protocol messages from the spec coming. The last message is, the first message in DI is 10, the last is 13. And so if everything works right, you'll see a message 13 from the spec, and you'll see a DI complete. That'll create a credential from you. Then any subsequent times you run the device from then on, those credentials are already created, so it won't have to run DI. And so subsequent running of the device, it will run the TO1 protocol for rendezvous, and followed by TO2. The last message of TO2 is message 71. So again, if everything works right, you'll see a message 71, and you'll see TO2 completed successfully. And so that's basically how you get started running these solutions. So we again implement all the FIDO specified protocols. There's the DI protocol, which is non-normative, but all the normative ones as well. TO1 and TO0 are rendezvous protocols. And then the TO2 is the main protocol between device and ownership servers. There are APIs that we have. One tool you can use, you can run all the APIs from the command line using curl, wget, whatever your favorite command line utility for invoking Rev APIs. In this example I'm showing you can also use Postman. I usually use this during development, right? If you just want to run Postman to call the APIs to configure your server. So one thing you can do once you set up Postman, you can just do a get on health, and that will return, show that your server's answering and healthy. And then you can also configure Postman to do TLS certificates if you've configured it to do full TLS. And so you just go into Postman and configure your certificates that you generated from the scripts that I showed previously. And then once Postman's configured to do TLS, you can start executing commands. Now, one thing is we issue initially all the certificates on the all-in-one. It's just running everything on the same machine under Docker host, and so we issue all the certificates to Docker host. So if you want to make sure your client can resolve it, because it's probably not going to be in DNS, right? Docker host, you edit your host config file and just put the IP address of your local host in there and map that to Docker host. This is only actually if you're going to run the device outside the container. Inside the container, you don't have to do this. And again, this is just for TLS resolution, right? You don't have to do this if you've configured it to skip TLS and TLS authentication. And then now you can, if you've configured it for TLS, you can do the TLS version of help, and it should answer. And then there are things you can start invoking APIs. And so to invoke APIs, you in the README file for all-in-one, it has a table and it lists all the APIs that you can call and what the inputs are to them and the outputs. And so if you go through the README, then you can go to Postman and you can just put the body that you want to post in the message body and the API call in there, and you can just hit send and start sending. This is an example of where we're setting up the manufacturer to tell it what ports and servers to contact for rendezvous. And so I can just type in the CBORD diagnostic form of the rendezvous instruction there and hit send, and that would set it up. Another one that you would likely want to configure is your the rendezvous information for an owner, and you can post that as well, the owner block. So again, you can use whatever tool you want, but this is for just showing visually through Postman. You can make REST API calls to configure your own. Again, there's the service YAML is worker section. The worker section in the YAML, so the YAML is the configuration file, and there's various worker objects in there that perform work when the FIDO protocol workloads are being run. And so there's certain useful workers when you're doing debug. Again, we designed it so it's most secure up front out of the box, but then which is very useful when you're deploying. But for debug and for development, you may want to change some of these workers. And one of them is enabling the debug exception consumer. This allows any exceptions, full exceptions, stack traces from Java to be outputted and to the logs or to the standard out. And so by default, again, we don't log exceptions for security reasons. So you can enable that during your development. And that's just useful so you can see, have some way of diagnosing issues. Another thing is the rendezvous server by default only trusts certain public keys. And so unless you've set up a public key trust there, you won't be able to do TO0 with the rendezvous server. So another useful thing right out of the box for development is you would enable the untrusted rendezvous accept function. And so that when you enable that, basically your rendezvous server will trust any ownership voucher submissions over TO0. And again, that's something you'd probably want to do and be very useful during development. So those are very useful things. So you'd uncomment those and then comment out that you wouldn't want to use the trusted rendezvous accept function during development or the standard exception consumer, which gives minimal logging output. And so once you've made those changes, then you can again bring up the containers and have debug and easier usage of the all-in-one. And I think that was the last slide for going through the LF Edge implementation of the FIDO protocol. I think I can leave some time for questions here if anybody has any questions.
Thanks so much, Randy. I don't see any questions quite yet. That certainly was a thorough explanation and greatly appreciated.
Okay, thanks.